In problems A9, we have Myra standing on top of a small hill, screaming at the top of her lungs at an 11,100 hertz frequency. A duck is flying toward her, but the duck hears hertz. So he hears a different frequency because he is moving. How fast is the duck flying, and what frequency will be heard as he passes her? So here, the first part, she is obviously our sound source, so this is the frequency of the source. The duck is our listener, so this is the frequency of the listener. Well, who is moving here? Clearly the duck is moving, and the duck being the listener, we're looking for the velocity of the listener. So if we turn to the Doppler formula, that's FL equals Fs, V plus or minus VL over V plus or minus Vs, our listener so what we're looking at is the listener velocity up on top. So our source, since Myra was just standing there and she was not moving, then this part is going to cancel out. It's just going to be 0. If you add or subtract 0, we don't have anything to worry about. So the frequency of the listener was the 12,700, that was our duck. The frequency of the source was 11100, that was the frequency Myra was screaming at. Here the velocity is going to be the speed of sound in air, which we accept as 343, plus or minus the velocity of the listener, which in this case is the duck, divided by 343, which is the speed of sound in air, and again plus or minus 0 down there at the bottom. So if we're looking for this, first we want to get the parentheses all by itself. So this needs to come down, this needs to come up, and we're going to end up with 343 times 12,700 over 11100 equals 343 plus or minus VL. After plugging in, we find that that is 392 equals 343 plus or minus VL. Clearly in this case it's plus, so the opposite of plus is going to have to be minus, so we're going to have 392 minus 343 tells me the duck must be going 49 meters per second. So that's the speed the duck is flying. Well, no problem. Now, what happens if the duck goes past her? Well, if the duck goes past her, the only thing that's going to change is right here. The plus is not going to be plus anymore, it's going to be minus, because it's plus when it's coming toward, it's going to be minus as it goes away. All the other numbers would stay the way they were before we did the algebra. So now that we know the 49, we got it made. So coming back here, all we're doing is grabbing our duck, and our duck is flying, and as the duck goes past her, now suddenly, again, that's going to be minus. So if we have these same numbers, and we can just kind of erase the algebra part, and we say, well, if we're going to deal with this part up here, this is still 343 down here. But if we have this, but now this part is definitely minus, our velocity of our listener we just figured out a second ago was 49. So that's going to change our answer, of course. This is no longer going to be 12,700. It's going to be lower than the 1100 because it's going away. It's going to have a drop in frequency, that red shift, as it goes down. Plugging that in carefully into our calculator, we find, of course, that that is 9514. Since we've only got 2 sig figs, we're going to round that up to 9,500 hertz is what the duck hears past. So again, when the duck was over on the front side, when he was over here coming toward her, the frequency he heard was higher than what was actually being produced. But once he flew over to here and he's going away from her, the frequency we heard was only 9,500 hertz, and so the frequency dropped compared to the original frequency. And that's what we will always see.